and myself, Jobin, currently working as Postgres escalation specialist for Percona. And today's my topic is highly effective troubleshooting and performance tuning. Yep. And today's topic contains some real world cases, because just talking about some abstract things won't be useful for you, and some common mistakes and frequent troubles people faces, and how we can identify those problems. And we should start looking at things from host machine onwards, the host machine configuration and performance, PostgreSQL performance and its stability, and right sizing, because now everyone is conscious about the cost involved. So we should have a proper sizing and good design and development practices. And today I am not going to cover the SQL tuning part because time won't be sufficient for that. Okay, rushing to the topic. So always we should remember that there is three sources of problems. Okay, and the first one is host machine and the infrastructure we are going to use. That can give us a lot of trouble, and the PostgreSQL configuration and the workload. Obvious. So when we start looking at things, we should look at all these three things separately, and the information which we collect also should come from these three sources: the host machine configuration and analysis, the Linux tools which we can use, as well as the Postgres performance and the stats information, performance stats. And the last one and the most important is Postgres logs. So I see some of the cloud providers calling it as error log. Maybe they didn't understand the meaning of it, but yeah, the Postgres logs is the ultimate information for any troubleshooting. And if someone engaged in fixing the problems, should look at all these three things. And when it comes to the host machine, the most important thing is the memory, how you configure your machine's memory, because a database workload is all about, say, the queries, how easily it can retrieve the data. So the memory configuration is super important. So before starting my the detailed analysis section, let me go through this first, because this is the foundation. Database servers needs a lot of RAM. So if you are in a cloud instance, look for instances with the memory optimized instances with a lot of RAM, which gives maximum value for you. Generally, that in a general database, the active data set is the data set, I mean the tables and indexes which are frequently queried. That won't fit into the memory. So look for instances with maximum RAM, not CPU RAM. Okay, and when you configure, look for this whether THP is already enabled or not, because database workload won't play nice with the THP. And instead, we should look for persistent huge pages. Huge benefits we are going to get out of that. I'll just rush through that. And I have blogged about that. Anyone who are interested, just Google this title, why Linux huge pages are super important for a database workload. And this is not only for Postgres, any database workload, huge pages is super important. Okay, I think that you can see that properly. The damage which the default settings of Linux can cause. So the Linux counts the memory utilization in terms of the process touching the pages, because we are using a shared memory, and lot of process will be using the same pages again and again. So every process which is touching a page will be accounted for that process. So ultimately what happens is the checkpointer and background writer will be accounted for a lot of memory usage, but actually they are not. This is a bad accounting practice from the operating system, because the OS is a very generic stuff, not designed for a database workload. So we need to be aware about this. So the ultimate result is if the system is running out of memory, it will, there is a high chance that it will kill the checkpointer or background writer. So this answers that question, why checkpointer and background writer will get killed in a out of memory condition. And THP is bad for database workload because it causes a lot of memory fragmentation and memory allocation will be slower. So that need to be disabled, and disabling should be on the bootloader side, because many people do it in a dynamic way, and what happens is after the system reboot, that will be lost. So disable it in the bootloader grub. And if you look at the THP impact in /proc memory information, you can see that the page table size is, in this case, is 29 GB. So this is a typical case, but yeah, it's common to see that page table running into hundreds of MBs or GBs. 29 GB, and here we can see the anonymous huge pages is used and no persistent huge pages are used. So this is how a database server should not be. Wrong configuration, okay? And once we configure the huge pages, we can see that, okay, 32 GB shared buffers is fitting into few thousand pages, 16,000. And see, look at the page table size, it is drastically reduced to 60 MB. Where is 29 GB and where is 60 MB? Huge difference. And if you look at those blog posts, I even tell how much the per process accounting is reducing, and Postgres may not become a candidate for another out of memory killer easily. So we can protect the database just by putting huge pages in place. And the other areas where we can fine tune is the memory, reduce the sloppiness. So this is common for all databases, not just Postgres. Yeah, reduces sloppiness to some single digits like below 5. Linux comes with the default some 60, which is too big for a database workload. And storage side tuning, file system side tuning, and selection of right file systems. Say ext4 and XFS is good for database workload. And the mount point options, I think everyone is aware about this no airtime, because every time the database accesses a file for reading, it is accessing. So that access time need to be recorded on the file. So when the file is accessed last, so Linux will update that information. So every read operation will result in a write operation if airtime is there. So that can be avoided. Actually, we don't need to have that level of monitoring. So, and in Percona we have a toolkit. Percona toolkit is free and open. It's just a Perl script. You can download it and use it. So it will figure out all these mistakes generally. And if you are not happy with the Percona toolkit, you can directly use the Linux tools, vmstat, mpstat, all systat packages, iostat, pidstat, and other things. So all these tools will be very handy, and it can clearly tell you where the things are going wrong.
Can you just elaborate on sloppiness a little bit more?
Okay, say when we have the question is why we need to reduce the sloppiness. So look at it.
You're referring to swap area, right?
No, sloppiness, the operating system property for pushing something out of. So yeah, maybe you can reserve this question for last. Okay. Yeah, okay, yeah, we'll address. Yeah. Yeah. So moving quickly to the Postgres side, PostgreSQL performance and stability, and we should remember a database workload is always IO centric, IO intensive, and I need to assert this multiple times because there are marketing strategies coming in and saying that you can have multi-node machine for a database so that you'll get a lot of CPU and memory. And that is, the computation power is not the real bottleneck in a database workload. It is the I/O. And that is the fundamental understanding every DBA should have. Because the database is all about storing your data persistently and retrieving it. Storing, retrieving. This is I/O. This is what database does. And what are the types of I/O? The most heavy I/O is value generation because it is synchronous. It need to sync the information to disk and get the acknowledgement back for committing a transaction. So synchronous write is heavy. And then second biggest workload comes from data file read because of the select queries. It won't fit into memory, so data file reads will happen. Then data file writes, of course, and in Postgres, 3 things will be doing that data file writes. It is BG writer, checkpointer, and each of the sessions also will be doing the cleaning of dirty pages. And autovacuum workload. This Postgres need to again bring back the content into memory, then clean it up, again write it back. So again I/O, temporary files. So majorly I see that a lot of people write queries, select a star from table, join with another thing. So effectively, lot of data will be fetched into memory and sorted, joined, and it will result in temporary files generation. And it is common to see that per day temporary file generation going up to terabyte. And see, if you have a proper monitoring, you'll come to know about all these problems. And then temporary tables, because we should understand that people are moving from other databases to Postgres, and they think that the temporary table works as good as other database, but not. There are problems with the Postgres way of temporary table implementation. And finally, the Postgres logs. So these are just list of things which are causing I/O. These are, I didn't cover everything. There are a lot more I/O happening in the system. So once we tune a database to its perfection, we'll see that the remaining bottleneck is the I/O, which we have very less option to address. Say you can buy a faster disk or spread the I/O. Yeah, so we'll talk about that. And this is a slide which I stolen from Google's presentation in 2008 by Jeff Dean. The number everyone should know. So the L1 cache access is less than a millisecond, and the slowest part is the I/O. And this is where the Postgres any database workload comes. And this is 2008 slide of Jeff Dean, and this is how it looks today. Still, this I/O is at the bottom. Even after having all these SSD improvements and things like that, the world is not changed much. I/O is the problem. And if you listen to the Google presentation, they are also the AlloyDB and all, they're trying to address this, the I/O problem. They have specialized disk. Yeah. So everyone is behind this because once they understand the bottleneck of database systems. Okay. And another thing is the connection management, which we try to address in different ways, because the establishing a connection is so heavy in the system. So look at the secure SSH, certificate authentication, or new SSL authentication. Lot of handshakes happens initially, and process need to be forked. Then authentication, authorization, whether this user has an access to this, all those checks need to be done, and allocation and the memory allocation, user settings, all those things happens. So there is lot of work happens when a new session is getting created. So I consider this as you are checking into a flight. So before onboarding, you have to do all the security checks, all those things. It is a 1 hour process. It's a heavy operation. Similar way, a new connection is established. And it's a common mistake that after establishing a new connection, they'll be sending only one query. Okay, select something from the one table. So the amount of effort required to establish a connection and the amount of effort to answer that query is totally, say the connection establishment is so huge and the query execution is so small. So the amount of wastage is hundreds of times. So making a persistent connection with the database is super important if you are concerned about the performance of a system. And how we can analyze this? So we can have a log connections and understand how frequently connections are established and disconnected. Postgres logs can tell you. And other option is to use pgstat activity. And tooling. And what if you have a very super helpful tool which can clearly tell, okay, you have a problem. Say your 67 out of 67 connections are new, fresh connections. This was the thing, the tooling which I was looking at for some time, because the work I handle in my day-to-day life requires this, to highlight all the problems. And yeah, this is another case where majority of connections are new. And so at Percona, we started an effort to create a script or tool which can help us identifying the problem. So it is there in the GitHub. Please feel free to use it. It is not a big tool, it's only SQL, but it is super efficient in finding out the mistakes, where things are going wrong. Okay. And the challenge which I face in my day-to-day life is, say, I feel myself as sitting as a person sitting in an emergency room of a hospital, because the customers comes with their database saying that, oh, things are not working, everything is stuck, and immediate, urgent, this is urgent, need to be fixed. So there is an emergency, and I have less time to figure out what is going wrong. So early days, for years I accumulated all the important queries and analysis queries. So initial days I was sending, okay, execute this query, show me the result, execute that query and show me the result. But that was taking time. So myself was in a situation like operating an emergency room patient using tooth and nail without any tool. So that was not efficient. That's why we started this project. And I got all the support from our team. And yeah, so coming back to the connection management, what we can do. So generally we talk about the connection pooler, and yes, sometimes the connection poolers are oversold because there is already a connection pooler in the application. So our first priority is to tune the application layer connection pooler. If that is not working, consider an external connection pooler like PG Bouncer. Okay, and the features, generally we talk about reducing the reconnection overhead, but the connection poolers has lot more advantage, just not reconnection saving. It reduces the idle number of, we can reduce the idle number of connections because the same database connection can be reused again. So multiple application connections can be multiplexed over a single database connection. So 3 to 5 connections can serve maybe hundreds of application connections. So
Is there any need to have application layer pooler at all? Just disable it?
see, application pooler has its advantage. Yeah, and the most important feature of this connection pooler is connection queuing. So one question generally I face is, say, what if application requires thousands of connections? If you have connection pooler, all those incoming connections will be kept into a queue. So no connections will be denied. It will be there in the queue. As database can process the initial connections, the rest all things will be served. And the advantage is, all the connections won't create a contention in the database, jam. So instead of creating jam, this connection queuing will ensure that a streamlined execution. Instead of causing jam, this will streamline the things. And we have blog post on how efficiently it increases the total throughput of the system. It actually, the queuing actually increases the throughput of the system. You will get better TPS by implementing this connection pooling because of the queuing. And auto vacuum. And this is a typical case, common mistakes. In this slide, we can see that there are large number of auto vacuum workers are running, and they are working on wraparound prevention. And some of the workers are started 2 hours or before that, 2 to 3 hours. So what happens is that general thinking is that we can increase the auto vacuum workers, that will speed up the things. So in this case, the customer has kept a auto vacuum max workers to 12. But what happens is the just reverse. When we increase the auto vacuum workers, things get slowing down, because these auto vacuum workers need to share the vacuum cost limit. So as we increase the workers, each worker will get a smaller pie. So the workers each worker will be running slower. And this is a very common mistake which I see, so I want to highlight this. And in many systems, we see that this auto vacuum workers cost limit is disabled because that is the default. And if this is the case, what happens is Postgres will take the other parameter, vacuum cost limit, which is 200. So we have the vacuum so small, the cost available is so small. So all the auto vacuum workers will be running very, very slow. And the biggest tragedy here is, say, as the workers takes longer time, we can see that there is a xmin reference, which is, say in this case, 235,000 old. So auto vacuum workers are referring to an xmin of such an old xmin. That means auto vacuum won't be able to clean up the dead tuples created after that. So basically, the slow running auto vacuum will defeat its own purpose. So the best we can do is reduce this max workers and put this vacuum cost limit to something meaningful, like 500 or some value. And make sure that this vacuum workers are not running too long. If that's taking too long, it will destroy its own purpose. Yeah, and the wraparound prevention auto vacuum. Many times DBAs look at the table age and see that it shouldn't be candidate for the vacuum, the wraparound prevention. But one thing often they forgot is there is a toast associated. The toast may be aged. The aging toast, the last column in the PG Gather report, shows that those things, that the toast is getting aged. That's why the wraparound prevention is happening. So these are the things which we'll come to know if we have a clear-cut tool in front of us, and which will produce such a result with the problems highlighted in red. So our eyes can't miss that problems anymore. All the problems will be highlighted in red. These are the problems. And yeah, if you are not interested in tool, there are queries. You can download my slide. It will be mentioned. And temporary tables. Personally, I consider this as one of the worst thing in Postgres. So the implementation of temporary tables. And the community is aware about this problem, and we have been discussing for years now. This happens when people migrate from other systems, because there are much efficient standard compliant temporary table implementation in other databases. Postgres is yet to have a good one. Hopefully it will be solved in future. The problem is the temporary table will remain only for one session. Every session need to create a temporary table. And when every session creates a temporary table, it will blot the PG class, PG attribute, all system tables, it will add that entry and it will get blotted. And it is common to see from when users uses this temporary table, auto vacuum will be running on those system tables. Yeah, and the temporary table spill to disk and causes more I/O. So if you have a development team, discourage them from using temporary table. Instead of that, use something modern like CTEs. We don't have to have a temporary table to hold something. The modern CTEs are much efficient. We can replace many of the existing logic with the CTEs. So how to detect whether your system is having is using a temporary table? The problem is, since the temporary table is session specific, the other sessions won't be able to see whether a session is creating a temporary table. So your regular toolings won't, or the queries can't tell you whether the temporary table is in use or not. And sometimes it happens that the session creates temporary table and uses it and then disconnects. So no one will be aware of whether a temporary table is created. So the workaround for that, okay, of course, I use a different method to detect the temporary table usage, because the temporary table will create a temporary schema. That is the indication that they are using temporary tables. So in this case, more than 1,000 temporary schemas are created. So this way we can detect, okay, there is some usage. So our report should highlight, okay, there are huge temporary table usage. And indexes. This is another common, say I get this question always. Say some customers will come up with some query and say that this query is not using indexes. Do we need to do something about that? Actually, indexes are not always that great. Okay, you don't have to worry about if some query is not using indexes. That's fine. It can still run. Indexes are not cheap. Say the assumption is that indexes are damn cheap and it will be always beneficial. But it is not cheap. It comes with a big cost, because every DML operation need to update all the indexes. So if you have 5 indexes on a table, if you insert one row, the table insert is one part and 5 updates happens in all the indexes. So the insert workload is multiplied by 5. And another problem is the indexes are, so the regular index is B tree. So normal insert operation to table is simple because it is adding that record to the same page which is already there in the memory. But if you want to insert a record into a tuple into B tree, it's a tree structure, so that can go anywhere in the tree. So it's a random write. It is much more costlier. And indexes will definitely generate val. And indexes need to be cached. See, this is a problem. Even if you are not using indexes, the index is not helping any query, still it need to be cached because that need to be updated. And it uses more memory, okay? And it causes random I/O and random data file reads and writes. And finally, the indexes also need to be vacuumed. So we talk about table vacuum, but actually the associated indexes also need to be vacuumed. Okay, and when we analyze this is a common case. Say the table size is small, the total index size is big. So it's very common to see 5-6 times size of table. So imagine the overhead which we are creating. Yeah, so the key point we should remember is the sequential scan. The table scans are not always bad. So unless there is a specific need to improve certain queries, we don't have to take all this penalty. So basically, when we create an index, we are saying that, okay, we can penalize the entire system, but I have a business case where this particular query speed is more important for me. So if that meets, then create an index. Otherwise, the indexes are more costly. And how do we analyze? So PGStat user indexes, and there is a script available in GitHub by PG experts. That's again open. That never used indexes, multiple levels, never used indexes, low scans, indexes with high writes, and seldom used large indexes. So multiple criteria of the bad index usages, and of course the script which I mentioned, PG gather. And there all these problems will be highlighted. Index usage is 0 in many cases. It's directly from PGStat user indexes. And new update is Postgres 16 will have one more column added. The upcoming version Postgres 16 will have this column, last index scan. So this is again important because an index which was useful in some time back, it will show the index usage if you are not resetting the stats. But if it is not useful in modern days or last few months, then this age will tell when was the index last used. So it's a good candidate for dropping off those indexes. And foreign case, people again never bothered about the cost associated with the foreign keys. It is very costly. Checks are not free, they are costly. So assume that you want to insert a record. So we talked about inserting a record into the table and the associated indexes. Postgres need to go and check whether this key is there in its parent table. So the parent index also need to be brought in. And not just this one. Say we have customer cases where they implemented data retention policies. Okay, the data which is older than this should go out. So when they execute that, it is taking too much of time. When we analyzed this step by step, we understood, okay, the data deletion is taking time because of these foreign keys. So it's not cheap. And if foreign keys are failing, fix the application logic. I need to stress this because there are application logic which depends on the foreign key failure. So basically they roll forward the transaction, then the foreign key fails and they roll back the transaction. See, look at the overhead it creates. Never do that. And for most of the cases, just a not null column with the proper data type will serve you. Say, think about a typical order and order details table. So if order details has a not null column about order ID, and if it is say integer type, people cannot insert any junk there. So unless your application is so messy and it generates some random value and puts it, yeah, that's a different case. Otherwise, that not null check and the proper data type will ensure that you have a sufficiently intact data there. So you don't have to enforce a foreign key. And we should remember that we are living in a world where NoSQL is existing, and that is something really scary for me. No schema, no data type. Oh, there are people dealing with that. Then we can live without foreign keys, of course. And personally, I consider foreign keys as the training wheels of a cycle. So if foreign keys are failing, that means the person still don't have balance. The application is problem. So we need to get the application fixed. And if somebody want to have the checks while inserting or updating data, even we can do without foreign keys, because the insert statement can have a select statement, include explicitly included. So always explicit statements are clear and yeah, it is easy to understand than an implicit magic happening in behind. Okay, and coming to the wait event for tuning. So I think there was another session by somebody about wait event, and the beauty is that you don't have to use any tool or any special service or anything for understanding the wait events. It's damn simple because it is available in PGStat activity. Okay, you just need a script which can take out that and present to you. Okay, that's it. You don't you don't have to worry about whether I am hosting on some cloud services or on-prem or this this works everywhere. You can use it, and in this case, yeah, it highlights the CPU usage, what percentage of CPU time it spent on CPU, client read, client write, and val writes, of course, data file read. And this is another case. Here we can see that the number one wait event is transaction ID. You know what it is. If there is a transaction ID wait, means some session is blocking other session from doing its work. It's a contention, the jam, the blockings. So if the transaction ID appears in the wait event list, the application behavior need to be corrected. So because it is causing jam. And here we can see the val writes, val sync event. So this shows how much the system is slowing down because of the val writes. As I mentioned, the IO is the bottleneck here. And here is another example where the val write becomes the topmost. So all these are from real production systems, okay? And solving this problem is damn simple. Move the pgval directory to another mount point, a faster disk. It's so simple. And I dealt with a customer, and when I said, see, this is your problem. Say, your transactions are slowing down because of the val write and val sync. Just move the pgval directory to another mount, your problem should be solved. And he done it, and he came back and said, no one told this till this time. It's such a low hanging fruit, so simple to fix. And spreading of IO. Have a dedicated mount point for vals. If that val writes or val syncs is a major problem in your system. And if there is lot of temporary file generation or you have a temporary table space, and there are some little hacky tricks that the temporary table space can be moved to memory file systems like dev, SHM, or some temp file systems that in specific cases that will give enormous speed up. And use always table spaces. There is no point in having old partitions lying on your current SSDs. Old partitions can be moved to some compressed storage like ZFS or use the Postgres features to have table spaces. And if you are using the OLTP workload, you may be using a lot of the staging tables. Create unlocked tables because the data need not be living forever. It's cheap because this won't generate val. And dirty page writes. I already mentioned there are 3 ways the dirty page writes happens. The background writer will write the dirty pages, and the checkpointer will write dirty pages, as well as the Postgres, each backend also will write the dirty pages. So in this case, we can see that the clean by backends is 93%. Individual backends are cleaning 93% of dirty pages. So what happens here? Individual backends means the user session need to clean up first. So what happens here is the user session need to bring new pages from disk to memory, and the user sessions are not able to see a free space in the memory, and it need to clean up the pages first and place its pages. So first clean up, then place it. It is a lot of delay, and actually the checkpointer and BG writer can ensure that there is sufficient free space available. Then the individual backends need not wait for cleaning up. It can just occur, and so all these problems can be easily detected if you have some script in hand. Because yeah, in this case we can see that the cleanup is done by the backends is 63%, not too bad. Here is another case. The BG writer is almost doing nothing. So that is supposed to do a lot of cleanup, but it is doing nothing, and 83% is need to be done by the backends. So these are the areas which we can fine tune if we have the proper information in hand. And where to get the information? PGConf BG writer. So if you are not using any tool, query on this. And say you need to understand the fields, and yeah, so you look at the Postgres documentation for details. And the data file reads. Okay. When data file reads happens, so in this case, data file reads is the number one wait event. That means the Postgres spends a lot of time in reading data from disk to memory. This is an indication that there is not sufficient cache. The memory is not sufficient. Always the Postgres need to bring from the disk to memory. So it spends a lot of time in. So this comes to the place where right sizing. So where should I spend my money? Here we'll get maximum benefit if you invest money on RAM, not CPU. In this case, it's a second most wait event, and we can see the client read. It can be problematic, indication of problematic behavior. Yeah, and this is the IO stat information when there is lot of data file read happens. This is from the Linux tools, the sysstat tool. Here we can see the read requests are higher than the write requests, and because of the extreme read requests, the queue size is increased. So the disk the read requests need to wait in the queue, and that is leading to the disk utilization of near 100%. So what we see in the database at the Postgres side can drill down to the OS side. So this is happening in the database side. So it is happening in this read. So it can be correlated. That gives a clear picture what is happening in the system. And yeah, oh sorry. So I need to be really fast. Sorry. If this happens, you need to be really looking at the data retention policies to reduce your active data set and partition big table so that your active data set will be reduced, and remove the seldom used unused indexes. Oops. Just close that. And improve the architecture, transaction management. So in this case, we can see this is idle in transaction, but what it is doing, it's client, the wait event is client read. That means it started a transaction and doing nothing, or send some statement. It sends some statement, and without committing or rolling back, it is just waiting. It is as good as parking your car in the middle of the highway, causing complete jam. Okay. So all these need to be addressed in the application side. So if this happens, escalate to the application developers at the earliest. And this is the indication of temporary file generation. Sorry, I need to be rush. And in this case, we can see 1.4 terabyte of temporary file is generated per day. Assume the amount of I/O it creates. So in that case, fix the application logic, be bit rude on the developers, and contentions and blockings. Generally, we have the regular query which is on the PG log statement. The problem with those queries are it will give a big list of the jams. Some session is blocking other session, that session is blocking other session. So if we analyze that properly, we will see that one session blocking other session, that session is blocking another. It forms a chain, and we don't know where that chain begins. So who is the friend of the blocking? When we have a tool, it is easy. Okay, this guy is blocking the rest of the things. So if we terminate this one, the blocking is gone. So this is where the tools will help. So otherwise, we need to figure out. Okay. The configuration problem, say checkpoint. This is the most common thing. There will be a lot of force checkpoints. 90% force checkpoints are common. And problem with the force checkpoint is unforeseen spikes. So when the overall transaction increases, the force checkpoint also will increase automatically because the threshold is reached. And this is time you should think about tuning your checkpointing. Max val size, min val size, checkpoint timeout. So generally in production system, 90 seconds to 1800 seconds is what we can really use. And if you are having HA framework, the crash recovery time is not really matter for you because if one node goes down, the other node is taking up. So the crash node can take its own time. And the tool should tell us what is the current val generation speed. So at least 1 hour of worth val retention is we should target. Configuration problems. So in this case, the report says that no vacuum information for large number of tables and no stats available. What happened is the customer turned off the auto vacuum. I don't know. Still, there are some recommendation in the net to turn off the auto vacuum, and people do follow that. And hot updates. Today, multiple times I heard that Bruce also mentioned the improvements happening in the heap-only tuple updates. This is area where we can get a lot of benefit if you properly tune the table. Say, basically, we need to adjust the fill factor. But we need some tool recommendation, say what should be the fill factor. So based on the number of inserts and updates, we can more or less calculate because the view gives us the current hot updates happening. We can do some calculations based on the current hot updates happening and the total number of updates. And this will save a lot of I/O and performance. So one of the biggest improvement in Postgres over last few years. Okay, and for DBAs there are a lot of things. I think we are running out of time. Good DBAs should influence the design. We identify the mistakes and escalate to the application team for fixing. Yeah. Moving on. If there is a crash, it should be detected and need to be analyzed. So the tool should help us on that. And the auto vacuum recommendations. Yesterday somebody asked how do we handle if there are too many auto vacuum runs on a table. The table level auto vacuum settings can be done, which can eliminate those problems. And the tool should again help there. And replication analysis. So generally we used to do some queries on pgstat replication and tell okay it is delayed, but are we really analyzing which stage it is getting delayed? Is it in the initial transmission stage or replica right side? So the replication goes through multiple phases. In which stage it is getting delayed? Then only we can address that problem in the real world. So if it is in this case, we can see that the transmission lag is high for one of the replica, but not for other. So that indicates there is no problem with the primary. There is something, the acknowledgement is not coming back from the standby. So the standby need to be inspected. So failing val archives, yeah, there's a common problem. Information is there in the PGStat archiver. Yeah, just rushing through. Replication slots. So in this case, it is holding that catalog xmin for so long. And I mentioned about the script and tooling. It is, the PG gather is a SQL only tool. It's a just SQL only. You can just collect the output to an out.txt and import that the data into a local machine. Again, SQL only. And even the report, the HTML report with all the, that also SQL only. So you can run it anywhere, Linux, Windows, Mac, cloud, yeah, containers, yeah, anywhere. Yeah, it's 20 seconds. Because there is, yeah. Yeah, that's a good question. What this tool does is, it has a built-in sleep for understanding the wait events happening. So it does a sampling. So you won't see that running always, because the 20-second sleep is there. There are the millisecond sleep in between. So it samples the wait events and comes up with a meaningful report. And some of the important links, yeah, please make a note. And Percona is currently working on this extension PGStat monitor, because that may help on further analysis on the monitoring tool side. It's an improved version of PGStat statement, in fact, yeah, with a lot more features. That's all. We are hiring. Please visit our. Thank you.
Thank you.